Hello, friends. This is Anshu. Today, we will be talking about system design of WhatsApp application. So, system design is very crucial for a software development role because it ensures that your systems are scalable, maintainable, reliable, and efficient to handle millions of users and large volumes of data. System design acts like a blueprint or architectural plan for building a software. In modern time, a system should be able to handle large number of users. It should be able to handle real-time data and should be available 24/7. Now, it also defines how different components in a system will interact with each other and how data flows. Um, it also helps engineers and software developers to plan for scaling, load balancing, fault tolerance, and caching mechanism. In case of incident, it if your system is well designed, you should be easily able to debug and monitor your system, and hence it reduces the downtime for your system. So let's talk about designing the WhatsApp. So WhatsApp is a messaging application, a chatting platform which allows users to send and receive messages. Messages can be in the form of text, image, videos, or other media files. Um, it also provides you a facility to make calls. You can make a video call or you can make an audio call. You can also set a status for a limited period of time, let's say 24 hours. It is usually the limited time for setting a status in WhatsApp application. So these are some important features that that WhatsApp provides us. Now, before diving deep into each of these features, let's talk about some important concepts that that we should take care of while building a system. While building a system, not just a WhatsApp, but any other any other application. So let me share my whiteboard, and we can discuss one by one all these concepts. All right. So the first concept that I want to talk about is user registration and authorization. So, your system should allow users to create an account and log into your system. In case of WhatsApp, user phone number can be the primary or the unique identifier. Then the second important concept is media compression. So, since we do not only send text messages over WhatsApp or any messaging application, we also share media files like images, videos, voice notes, or any other documentation. Um, so, you should have a mechanism to optimize the size and quality of the media so that you can enhance the speed of sharing and receiving those messages. Now, the third one is encryption and decryption. Um, let's say user A wants to send a message to user B. So only user B should be able to read that message. No one else should read that message. Um, so you should have a mechanism in your system that it will encrypt the message at the sender at the sender's device, and it will only decrypt once the message reaches to the receiver's device. No one in between able to see that message in a plain text, not even the WhatsApp backend. So this is a very important concept to have. The fourth one is push notification. So your system would like to send a push notification to the users once a user has a new messages or calls from his friends or any other user. The next can be support system. So system should provide a support mechanism or the customer service, let's say in the form of help desk and FAQ. This is also very important, uh, so that if a particular user has any query, he or she can reach out to help desk for any help. Now next can be scalability. So as over the time, today, let's say today your system is able to handle some thousands of users and some gigabyte of data. Let's say 3 years down the line, the number of user increased to 500 million and the data increased to 5 trillion, 5 terabyte. And now, um, you should be able to scale your system so that it can handle the increased number of users and increased data volume. The next important feature is data and analytics. What is data and analytics? What it does? So, as a good software developer, you would want to build this mechanism in your system to understand how users interact with your system so that you can enhance the user user experience and you can even enhance your platform performance. So, for example, we are talking about data and analytics. So, you want to collect some an aggregated data. You want to collect the user's data and you want to analyze that. For example, let's say you want to collect some usage metrics. For example, how many users are using voice notes more frequently. Let's say in a particular region, people are more frequently making calls instead of sharing the messages. Um, you want to understand what is the popular time of a day for a particular group of people. You want to understand the user's behavior, something like how a particular group of users want to navigate. They are navigating in your system, something like switching between chats and searching for a particular message, making calls, setting a status, or viewing and liking other people's status. So these are the metrics that you want to collect so that you can improve your backend infrastructure and enhance users' experience. For example, in a certain region, let's say in a region A, there are some thousand users and they are more interested in sharing voice notes instead of text messages. But since they are more frequently trying to share the media files, they are facing the delay. And therefore, after analyzing this data, you would like to optimize the media compression mechanism in that particular region. So this mechanism of data and analytics is also very important for designing a system. Now, the next concept is A/B testing. A/B testing helps you validate a new change before rolling that out to all, to everybody globally. So, for example, you are introducing a new change called new emoji reaction. You introduce you introduce this feature, and you want to understand uh, that will it be a good feature or not. So you before rolling this out to the all users, you just want to roll out 10,000 of users, or let's say you have a group A where there are thousands, 10 thousands of users, and you roll out these new changes to these users. Now you have another group, group B. Here also you have 10 thousands of users, but they do not have this new feature. Now you want to compare uh, between both the group, that what are the engagement. You want to compare engagement and retention. You want to see that whether my new feature is improving the engagement and retention of users in group B in group A or not. If engagement of users in group A is more than group B, then you would like to roll out this feature to all the users. But if this new feature reduces the engagement, users' engagement, they are not interacting with this new features, then probably you do not want to roll out this feature to everybody. Now, these are some eight mechanisms that we would like to uh, we would like to consider while building a software. Now, let's talk about all the important features of WhatsApp one by one, and we will deep dive into in all the features. So let's consider some important features of the WhatsApp. So, for example, one can be one-to-one messaging. Next feature is group messaging. Next is read receipt. Fourth one, let's say last seen or online, when you want to a particular user want to know about another user when he was last online. Then the fifth feature that we can talk about is setting status. So these are the five features. Let's talk about this one by one. So one-to-one messaging. Now let's take a moment and think how person A can send a message to person B. So there are two clients, client A or user A and another user B. They user A wants to send a message to user B. They have installed WhatsApp application in their phone and they are connected to WhatsApp on cloud. So there is a gateway which will be the entry point for each user to the WhatsApp's backend. So let's say there is a gateway one and there is another gateway which is gateway two. User A is connected to gateway A and user B is connected to gateway 2. This will be the entry point to the WhatsApp backend, right? So user A wants to send a message to user B, so it will send a request to the gateway that send message to user B, and this is my message, let's say. Now gateway 1 need to know which gateway user B is connected to. So the one way to have this information is gateway itself can maintain a database and it can have the information of user and gateway. So it can have information like user A is connected to gateway 1, user B is connected to gateway 2. The problem with this is if there are 100 gateways, all has to maintain this information. All has to maintain this information that gateway A is connected to user A is connected to 1, user B is connected to gateway 2. So this is a very space consuming thing. This is not a very efficient and therefore we can, instead of storing this information in the gateway, we can decouple it and have a separate microservice, which is, let's say, session service. So we have a session service, and it maintains a DB to store this information. User gateway A connected to gateway 1, B connected to gateway 2. And now this all these gateway will be communicating with the session service. So when A is sending a request to gateway 1 that send this message to user B, now gateway does not know what to do because it does not know which gateway user B is connected to. So it will send the same information to session service. Now session service knows that there is a user A and which who has a message for B. Now it will look into the database that to which gateway B is connected to. So the B is connected to gateway 2. So it will route that information to gateway 2, and gateway 2 will deliver this message to B. This way, user A is able to send the message to user B. Now, before moving to the group messaging, let's talk about uh, the third feature that we spoke, which is read receipt here only because it will be easy to understand. So, read receipt is like if my message is sent or not, whether it has been delivered to the target audience or not, and whether it has been read by the audience or not. So, user A, the once it makes a request to the gateway 1 routes that message to session service. Now, session service stores that information that I have a message for B, I have a message from A, and I need to send that to B and B. So once session receives that message from A, that i- send this message to B, it will send an acknowledgement message. It will send an acknowledgement message to gateway 1 that tells user A that your message will be sent, delivered to B. So it will give a it will a user A will receive a sent receipt, which is like this in a WhatsApp messaging that your message has been sent. Now, once session service finds out that B is connected to gateway 2 and it routes that information to gateway 2, and once the gateway 2 delivers the message to user B, user B will acknowledge that, see, I have received this message. So there will be an acknowledgement from user B to the gateway 2. Gateway 2 now sends this acknowledgement to session service, and this will again be routed to the user A that your message has been delivered. And this comes as a double tick in your WhatsApp messaging application. After B reads that message, there will be another acknowledgement that I have read this message, and this read receipt is again routed to the user A, and this double tick gets uh, turned into a blue color. This is what we usually see. So this is how we also covered the read receipt mechanism feature of the WhatsApp. Now let's talk about group messaging, which was the second feature, group messaging. So let's say there is a group called group A, and there are 5 users, or let's say just 3 users in it for the sake of simplicity. So we have user A, user B, and user C. Now, or we can even consider one more user, let's say user D. So we have 4 people in a WhatsApp group called group A. Now let's say group A is connected to gateway 1. Group B is and group C also. Let's say they are both the users are connected to G2 and D is connected to G3. Now, this person is sending a message to gateway 1. It is making a request that send a message to the group called group A. So what gateway do is gateway 1 does not know that what I need to do. So it will route the message to session service. Again, let's say we are avoiding single point failure. So there will be multiple session service. So the message from A is routed to the session service. Now, sessions have this information that there is a group ID, group mm, ID, let's say group ID and users in that group ID. So it can maintain a separate database to store group information like group ID, group name, and other information like number of users in the groups and user users ID. For example, B, C, and D. So this is the database that session service might want to maintain. There was another database um for checking uh, for information like which user is connected to which gateway. So it has the information like B is connected to gateway 2, C is also connected to 2, and D is connected to 3. Now what it will do is it has the message from B. Let's say message is called message in the text format, and it will direct this message to gateway 2 that you need to deliver this to B and C. Then it will again direct this message to gateway 3 that you need to deliver this to gateway to user D. If there are another user who is connected, there is another user who is connected to this gateway user E, but this user is not present in this group. So G3, which is the gateway 3, should not deliver this message to E3. Message will only be delivered to the person who are in this group. So so we talked about that this session service can maintain this group information. Another way can be to decouple these things. We can have a separate group service. We can have a separate dedicated microservice called group service that will store this information. So session just has to uh, store the group ID. And for that group ID, once it receives a message from any users that this is the group ID, I want to send this message for everybody to everybody present in this group ID. So it will look into the session service, look into the group service to give me who all are, who are the users present in a particular group service. And group service now is maintaining all this information that there is a group ID and there are 10 users present in that, and these are the user ID. Now, those user ID will be sent back to the session service. Session service will look into its database to see which user is connected to which gateway, and it will direct those messages from A to all those gateways, and they'll then deliver to to the target audience. So this is how group messaging works in a WhatsApp application. Okay, let's quickly talk about next feature, which is last seen or online. If the user is online or not, And if he is not online, then when he or she was last online. So let's say there is a user A and there is a user B. There is a gateway, which is the entry point for WhatsApp. User A is connected to the gateway, user B is also connected to the gateway. Now, user B wants to know when was A last online or if he is currently online or not. So it will ask gateway, which is a server, to give me the timestamp, give me the information when the A was online. So what it will do is it will direct this request to station service. And let's say there is another microservice which is called last seen service. It is storing information like when a particular user was last seen, user and its last seen in a timestamp, right? So we want to know, user B wants to know last seen for user A. So how last seen service, how WhatsApp will know when user A was online. So any activity that A does on the WhatsApp, like chatting with somebody, making a call, putting in a status, or just navigating the WhatsApp application, checking someone else's status. So any activity that user A is going on WhatsApp application is being tracked by this last seen service, and that time stamp can be stored as a last seen timestamp for that user, and that timestamp can be then sent back to the user B, which is who is interested in knowing when user A was last online, right? One important concept in that is a threshold point. So there is this last in service um, continuously trying to monitor the activity of A on the uh, WhatsApp application. Let's say A was online 2 seconds before, and he has not done any activity in the 2 seconds. So one way to store last seen can be user A was last online 2 seconds ago, or even we can say that he is online now, because we can keep 2 seconds as a threshold. It is possible that user opens the WhatsApp, he is still planning to do something, but that activity has not been tracked. He is still online doing something on the WhatsApp, not sending any request to the gateway, but uh, it can be taken as a online. So this threshold can be reduced just to have some real time information. It can be reduced to 2 milliseconds on etc. And once what it means is if a user was online just before 2 milliseconds, it can be considered as he is online now, and this information can be sent to the user B. Right. So we also covered last 10 feature of the WhatsApp. Now, one last point, let's talk about setting status. Okay, so there is a client or user A, and there is a gateway, and user wants to set a status, and it will be available 24 hours, and it will be viewed, it will be visible to all those people in his contact list, right? So WhatsApp allows what? So let's say user A has his uh, or her phone's address book, and there are 100 people in his address book. WhatsApp automatically detects those contact list from the user's address book, right? So once user A sends a request to the gateway that I want to set a status, and there is a media file, let's say image. I want to send a status, this image for the next 24 hours. Now, gateway will route this information again to the session service. Now, um, let's say there is another microservice for setting a status, which is called a status service. And let's say it is maintaining a information like a start time of a status, and then based on the start time, what will be the expiring time of the status, right? And it should also communicate with message or the message service. So this is message service is also responsible for uploading and downloading the media. So there is a it maintains media storage, which it stores the media, right? So yeah, so these are the message services. Message service and status service will come into picture while a user wants to send a status. Session service should also maintain or try to detect what are the people in A's contact list. And for all those people, it will try to detect in his database who is connected to which gateway. And again, it does the same thing. It will direct to all the gateways that, depending upon uh, who is connected to which gateway, it will direct that information that A wants to send this status, and this is the start time, this is the end time. Set this status for A and make it visible to all the people, all the users in his contact list.